So today we are going to solve. Today we are going to solve the three problem yesterday, right? So I solved this the fruit and the basket. To the basket. So I solved first three. This is this the longest substring without repeating character. You have given a string S. You have to find the longest substring without duplicate character. So it's just a simple question. I used a map and I use like it's not allowed duplicate character. That means in the sub array there is no any character which is present twice, right? That's why find the I use the map frequently. I see the character which is already present, so we have to eliminate that character, and we are maxing the length of the sub arrays and return the maximum length. That's it. This is one of the big problem. The like sliding window. Now next question. This maximum consecutive ones. Here given that you have a binary array of nums and integer k, and you have to return the number of maximum number of consecutive ones in the array. If you can flip at most k is one, right? So this is also like if the current element is zero, we have to flip and make it one. And if we make one, then we are using the k. That means we are decreasing the value of k by one, right? So here what we have to do, like if the current element is one, we have to nothing to do, right? One, and if the current element is zero, so we have to make a two, like here in this example, two zero in present. So we can make one, k become zero, and the length become like from here to here. It's become a five, right? Now let's again, if we make these two zero, again one. So we have to here length become like here, right? One, two, three, four, five, six. So length is six. Now if we make one here and one here, right? So this become a length of six. Right? So maximum subarray is six. That's why I use like if the number is zero, we increase the k value, and if the k become negative, so we started to add k value, like we eliminating the zeroth value from the left side, and if the if k is greater than or equal to zero, so we maxing the answer and returning the max. Right? Now this so this is the question, like you are visiting a farm that has a single root row of fruits arranged from left to right. The tree are represented by the integer array fruits, where fruit I is the type of the fruit I. In the type of a fruit the ith tree produces, right? So you want to collect as many as fruit possible. However, the owner has some strict rule that you must follow. So you only have two baskets. Each basket can only hold a single type of fruits. There is no limit on amount of fruit each basket can hold. Right. So starting from any tree of your choice, you must pick exactly one fruit from every tree while moving to the right. The picked fruit must be one of your basket. Once you reach that tree with a fruit that cannot fit your basket, you must stop. So like we have to maximize the number of fruit types we can pick up. So this is telling that you have to only pick up two type of fruits, right? That means there is exactly you have to pick two distinct type of fruits, right? So we can use here set as the map, right? If the map size is increases, if the map size is increases, we can use this map, another map, like storing the fruits frequency, yeah, storing the fruit type, and if the size of the map is increased by the that is greater than the two, so we have to eliminate the fruit type. Like we can take one, two, but we can't add the three, right? Because it's become three different type of fruits. We can take two, three, and one, two, one, three, right? So that's like two. I use the unordered map and storing the frequency. If the map size is greater than two, so we have to eliminate the type of fruit. Like we have to reduce which come to the window frame, right? So maximum length, we are returning the maximum length. And that's it. Now let's see the next question. And also I made this. I solved this yesterday, right? I'm not able to solve this. I am going to solve today. And this I solved yesterday. So this is we can use the first when I read the problem, I thought that I can use here the map, right? I can thought I can use the map here. So I also made map using the map, right? So this is my map implementation. Like we taking the prefix sum and storing to the map. If the goal minus prefix, if the sum minus the goal we find, so we have to add count only. That's right. So I use the map here and maximize the like sorry, not maximizing, but we have to find the survey, right? Which is sum is non-empty survey with the sum is good, right? So now let's see. And also I use the nums like then again this is the very famous problem. Like we can use the at least sum and at most sum. So I first I here I written a code like using the at least. Why at least? Like I used like let's suppose some using some we we have to make like goal at most two, like we have 0 1 and 2, and again we have to make goal at most one. So like here we can find like 0 and 1. So if we minus it, we can find the sum of two. So that's exactly the question one. Like we have to find the exactly sum whose exactly equal to goal, right? So we have to find, that's it. That's why I used here. If we increase the sum by goal, so we have to reduce the sum. Otherwise, we have just directly count the sub-array and returning. So we count the sub-array goal. We count the sub-array with the sum of goal and the goal minus 1. So I used one condition here, because if the goal is 0, so we have to like return the minus 1. We can't able to make goal minus 1. That's why I return simply 0 here. That's it. We can use the at most problem like here. I solved at most problem here. Right. This is the concept. Now let's move the this problem. So in the program you are given a string of s and integer k. You can choose any character of the string and change it to any other upper character of the English letter. You can perform this operation at most k times. Then the length of the longest substring containing same letter you can get after performing above operation. Right? So in this problem, what we have to do, like in the in one problem, right? In one operation we can change the character. In one operation we can change any character to the other character, right? Like uh, like here a, in the position of a we can use like change the character from a to z. That means we can change to 26 letters, right? Just we have to find which character, changing the which character we can get the maximum longest substring which contain the same character. So what was the my approach? Like i I used a maximum variable and use like character ch a to ch z. So we can get what we can get, like um temp, length, helper, s and k, right? And we have to maximize temp, length, right? And just we have to return max length, right? So we are maximizing with the calling function, right? We have to call like a character, right? Ch. Now we have to write the helper function. Helper helper function like a string s in a character ch. Now let's check the length is equal to 0. We have to make like the left equal to 0 and the 4, right? What we have to do, like if if the right character is equal to c, if it is not equal to c, we have to make k minus minus, right? If k becomes 0 and if the s dot left is not equal to ch, then we have to make plus plus and left plus plus. Now let's see if the k is greater than equal to 0, then we have to length is equal to max of length and the right minus left plus 1. So we have to return the maximum length. So just like the last question, we are doing this. Yeah, this is giving the passes the test cases. Let's see it's able to solve the question or not. Yeah, it's solved. So what I am trying to do here, if the character is not which is I want to make, so we can make using the k value and we increase the k character, and if it is still 0, that means we use the kth value, all the kth value are not able to use, so we check that we able to make from the right to left, we able to make same character, so we are mixing taking the that sub array here. And if the k is become negative, that means we use extra value of k, that means the k value is defined as 2, but we use the k operation in 3 time or 4 time. So we are eliminating the index from the left side, element from the left side which is not, if the element, if the left element is not the we character, like what I'm trying to say that here, like in the my first example, let's let's take a, let's made a one example, right? A a b a b c right, and k is equal to 2. So let's see. So here we make a, and if right, we we take ch is equal to a, right? So a, and if bai is not a and b is not related to a, uh, that means the b is not equal to a. So we have to make b is equal to a. We use the one operation. So we make a a b c a, and k value become here 1. Now we have here we have the 3 sides. Now we have to make like a a a c a, and we have a is equal to 0. So now we have 4 sides. Now again we have a a a a and a, right? But a become the minus 1. So if it become the minus 1, we have to remove from the element of from the right side. So if we remove a, it can't become 1 because it's, we can't change this. We are, because it's already there here. So if we and again eliminate the b, so it's become b. Now we have to a. So k is equal to 0. So this is the approach. Like that's I used here. Same approach. Now let's move the next question. The next question is the like count the nice subarray. Nice, count the nice subarray. So you are given an integer of array, right? You are given an integer of array. You are given like count the number of nice subarray. Given an array of integer nums and integer k, continuous subarray is called nice if there are k odd number on it. Return the nice subarray. If there are k odd number, okay, k odd number, okay. So like we can use here the odd even, or we can use here, we can change that like 0 1, because if we take the 1 a reminder of 2, odd reminder of 2, then it's become 1, and even reminder of 2, it's become 0. So we can use like 0 1 for better. Yeah. solution. Like here we have got. Uh, let me see. Right? Let me see. If we take from here, if we take here, right? So, so if we take here like making of zero, like one, they're old. So if we take remainder of all two, like it become one, one, zero, one, and one. And now the question is simple that we have solved here. The question becomes the simple we have used solved here, binary search, binary summary itself. Right, same question, it's become same question because we have provide like a goal, case true, it's become a goal, and this become the new subarray. Let me show you how to do it by my code. Like first we have to make a photo int x nums. So x is equal to x modulo 2, right? It become this. Now we have to make helper nums and k and minus return. Now we have to make nums k minus 1, right? So, so now let's just we have to copy from here, and now we have to paste here. Let's see this going to pass or not, the test cases. Yeah, this is going to pass. This is a simple question. If you understand the binary subarray with sum, so this is same problem. Just a little modification. That means you have to understand the pattern, right? You have to understand like a pattern that either the number is odd or the even. So we have to convert this that subarray into a binary binary representation. That means the binary some binary array, just like here given. This so this. Now let's move the next question. And the next question is like, okay, so what we have given here, you are given a string of s consisting only of characters A, B, C. You have to return the number of sub-string containing at least one occurrence of all these characters A, B, C. Okay. So this is again the simple problem, right? Now this approach I can show you the approach like this is the simple like at least at least if the map size is greater than equal to 3, then we have to the add count the subarray like n minus current index current index, right? So just we can use here like it's just a simple problem. Int left is equal to 0, right? We you can use here the unordered map, take character, right? The So we have frequency like S. Now let's see. Uh, if now we are adding, so like now we have to check like amp dot size, sorry, frequency dot size should be greater than 3, right? So we have to add like a maximum length, not a maximum length, it's a count. So we have to add like a count, right? Now we have to make a frequency of s dot left minus minus, and if the frequency of s of left from 0, so we have frequency dot erase erase s dot left, right? And we have to increase left. This is the problem. Now we have to only return the count. Let's see, this is pass all the test cases or not. Yeah, this pass all the test case. So this much you have to learn, right? How to find the from at least or at most. These two concepts, if you are learn, it's simple easy. I can show you like for the some at least or at most. Like like let's see. Let me show you. So first, let's see. First, let's see the at least, at least. Oh, I think at least and the at most, at least and at most. So like that. If you use the at least, right? Like if you use the at least, that means we have to find like a sum greater equal to given goal, right? This is at least, and the at most we have to find like a sum sum less than equal to the given goal, right? So in this problem, let's suppose we can use the type of question, both type of question. Type one, like if you have given to find the subarray subarray with some at least at least at least the goal, or type 2, if you have given you have to given find the subarray subarray with some exactly exactly of goal, right? These two types you can find it, right? So now same the problem we can use here, same, just like here become the at most, at at most. So how can we see that the first problem here, like if you use the at least problem, this is the simple logic, and if you can use the same approach of in the type 2 problem, like how can you like a given sum, given goal is like 4. Exactly. We have to find the 4 sum. Goal sum is equal to 4. Right. Goal is equal to 4. And this is this is type 2 problem, right? Now let's move the, so understand. We have to find like the, at least that means we have can use the sum of 4, 5, 6, 7 till infinity, like, right? And the, if we take, we can goal plus 1, so we have to find like a sum 5, 6, 7, 8 till infinity, right? Now let's suppose if we minus this, so then this and from this cancel out, we can get only the 4, right? Same approach, same approach is used here. Like if we use the goal, goal is equal to 4, so we have make like a sum 1, 2, 3, 4, and we can again call a helper function with a goal minus 1. So this become 1, 2, 3, 2, 2, 1, 2, right? Now if we minus these two all, like T1 and T2, if we minus T1 minus T2, we can get like how many sub-array with sum exactly is equal to 3. So that's the approach. Now, if you wonder, how can we find like at least goal, right? So this is the simple, like I use here at least, like if the sum, if the map size become the greater than 3, so like we can you make it with us, we can count like subarray with the 4 size, 5 size, 6 size, right? It's clearly tells me the in the that at least one occurrence of all these characters should be present. That means the size should be 1 3 of the map, and is clearly given that it contain only 3 characters ABC. This is the my approach. So let's move to the next question. So there are several cards arranged in a row. Like you have to find maximum point you can obtain from the cards. So you are given like there are several cards arranged in a row, and each card associated and number of points. The points are given in the integer array cards points. In a step, we can take from the beginning of from the beginning, right? One from the beginning and from each of the row. You have to take exactly K card, right? Okay. So your scoring sum of the point of card you have to take in. So you have to return the maximum score. Like we can use take from starting and from the ending. So we take the starting K. It's number 5. Now become the 5. Okay. From the beginning or the ending. Right. Okay, okay, I understand now. From the ending, it's like 1, okay, 1, 6. Yeah, this is good question. So, so now let's see how can we approach. Like this question allow us to take a element from the last or the first, right? So we can use the sliding window here, like we first take the kth element, right? Now we increase 1 and decrease from here. So this become this. Now again this become this. Now again this become this. Now again this become this. And now again this become this. Now again this become this. So this like what I'm trying to say here, I can write all the sub array, right? All, let me comment out first. So all the sub array, all the sub array, right? All sub array of k size, like one, two, three, and the three, sorry, two, three, four, and the three, three, four, five, and the four, five, six, and the five, six, one, and the six, one, one, and the one, one, two, right? This all the subarray of the k size. So we have to just take a maxima of all these subarray, right? So now let's see how can we implement this. Like we adding, decreasing with the size with the right, mm, right minus left plus one. Like that. Add up right minus left plus one divided by and side. So six, one, two, three, four, 6. If we take here, if we take here like this, if we take here 1, 2, 3, now so right 2 minus 0 plus 1 plus 7, 3 plus 7, it's become like a 10. So it's become 3. It's become 3. If we take a reminder, it's 5 minus 1. So 5 minus 1 plus like 5 minus, so 5 minus 0 again. And here 5 here, this, left. Okay, you can use the, you can use right, left should be, left should be right, right. Okay, here, here. If we have take a left, so I can use here like one left element 0, and the maximum sub is equal to 0. Now for right is equal to 0, right is equal to n, and the right is plus. So we have to make like a temporary sum. Temp, temp, temp sum equal to 0. Now just we have to add into. Now just we have to see like if the right minus left plus 1 plus 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 n modulo n, if it is increase the size of k, we have to decrease the sign from the left, just like that. So no, you are doing a mistake here. What I'm doing the mistake? All things are clear. Just add here left. Okay, left should be negative. Okay, and we have to is right here plus plus. Okay, if the left right plus 1 and minus is greater than 10, we have to minimize the sum. Like 10 sum. Okay, 10 sum minus equal to num nums left. Sorry, right, this, and we have to increase sum. We have to maximize only. Take the maximum sum is equal to max of maximum sum, then maximum sum. Right. Now let's see. Okay, we have not defined right. Right is equal to 0. Now let's see if the correct or wrong. If it skip the TLE, TLE left, I think this skip the TLE, right? So we have to use the another approach. What can be another approach? Like a 1, 2, 3, and if I use the from the approach like 1, 2, 3, 4, 5, 6, 1, take the three elements from the right. Okay, not the kth element. Okay, if the size is greater than the 3, take this. Now we take this much. Now we have to take this much. Now we have to take this much. Now we have to take this much. So just don't do anything. Just add nums. I think this might solve the problem. Right. So it becomes 2n problem. Okay. So it's become 2n. Not a, we have to use the 2n. 1, 2, 3, 4, and like 4, 6, 1, and 1, 2, 1, 2. We have to just use like left to get here only. Just left, just which right, left, one better than k. Just we have to use and left plus plus. Yeah. Just Just wait. Right, left. Let's see. Let's see. Just to left. Should be right. Can go here. Right, go here. Right, left here. Right, right, go. Again, not a no problem. And now the temp sub should be nums of right, right, plus plus. Now right minus left plus one, right plus one, left one. So temp sum minus is equal to left, left, and plus plus. Right now, maximum sum should be equal to max of maximum sum and the temp sum and right plus plus. With this, that is coming up. So you can't remove the overload. So just now, just add, right? Just add, just add the right, just add like a kth element, right? Just add the k, like, this much. Just take one, k minus one here. Yeah, just add k minus one. Just add k minus one. Now push back also I, just like this. With compiler error temp. Okay, just we have to use here temp sum. Now let's say is given expected size 12. That is name temp right left plus size temp minus one and the left plus plus temp maximum temp sum 1 2 3. Here temp equal to 0, so nums will be by this movement if left first take the okay, let's take a maximum right in the right minus left plus one square to then we have to maximum we have to maximum answer just like this and it's become 15. Why 15? How what 15 0 1 2. Oh, okay. Okay, it's become 15, right? Why become 15? Y become it's 15 like Y. How much? So let's print first. Check. Let's debug it. Right. Let's print auto x nums and cout x. Right. Let's see how it's become. Like we have to 1 2 3 1 and 1 2 3 1. We check 1 3. Should be now should be 1 2 3 left right. Answer add left and using the size. Now again fix size again 0. Increasing the size. Hit the left minus right. Okay, this becomes 3. So it's not become the it is 3. So it's a 6. Okay, right? Now again for this we have 2 3 5. Okay, again from this. Okay. Now I understand. I totally get it. The problem wrong. This is not the solution. So this saying that you have to take either from the one card from the beginning and the ending of the array to select. So like if we take one element here and take two element here, two element here, one element here, this like we have to proceed. First we have take the kth element from the first and the last we have take kth element from the last. Right? So this should be like a temp sum should be 0 max sum is equal to 0 and we have to just use the value for int right is equal to 0 and right should be 0 1 2 k and right plus plus. Now just if we take right from the left, now we have to take element from the just like so we have to take like a int sum from the left and sum from the right. Now add just add sum of kth element. No, just we have to take the right. Okay, oh, right. Okay, just we have to take the element from the north side from the n minus side, right? And it's become it's greater than n minus k. And the sum right should be nums of I. Right. How can we proceed like this much, right? This plus minus p minus right. Okay. Now, this much, this much. Okay, take this much element. It's become like take from the element one and take two from k minus one here. It's two minus two plus right. 3. So just this is problem just like take one element from the start, then k minus 1 from the end, two elements from the start, k minus 2 from the end, three elements from a start, k minus 2 element from it, end. This is the simple logic of this question, and I over exaggerate this problem, right? So now let's see. I used it like 0 1 2 1, 0, 1, 2, 3, 4, 5, 6. 6 minus 3. So we have to 3. So 0, 1, 2, 3. Greater, not greater than 1, right? Let's say we take first element from left plus is equal to um, right. Then we have add this. We have to remove last element, right? If we take the k, we have to remove this much element, just like this. So next question from the sum of right, just remove nums of last last minus one. Now maximize the sum. If the sum, if the if the last, sorry, last, you have defined last. Oh, we have to look here. Last, the last, if the last should be and minus k, then we have to sum right minus equal to nums of so nums of we have to remove like last minus one, just like this, and we have to return the answer. Sorry. We have to use like sum of left. So let's see what the result is this going. Again, this 7. I think I missed something. Okay. So we are not maximizing with the right sum. We will maximize it. Max, maximum sum of right, and maximum. Maximize it. Then it's 13 and add now add side. Okay. Now adding add the last number. I think this must pass the test cases. Let's see. Or it's give the wrong answer this problem. It's like we counter here, and from here, this, we take this, we can use this, Okay, so what we are doing to here, if you take this much problem, we have to take this, take this here. We can only take this much now. So either should be a starting like from the k, k plus 1, s square plus k plus 1, right? 0, 1, 2 is starting here, right? Either should be starting from here and go like here. So 9, 6, 7. If we take 9, 9 here, we can also can use it here like what's the problem, but let's say what is going from the start at the starting. Okay, okay. Now I understand clearly what the last element should be. This is that okay, less than equal to minus. Okay. Yes, we have to write, right? Not write minus equal to so elastic, elastic, and elastic, elastic, elastic. This again, this why this the case of this is why this is feel like why 0, 1, 2, 3, 3. Stop. Take the 10, where minus the this much, it will become this, and with this much, which great plus, right? So we will become minus by 53. Now this becomes it, 140 plus 53, 100 and 40 plus 73. Yeah, it's 115. Now we have taken like 150, 73, 75, 8, 4. If you remove that, okay, first case and increase the case. Right. This giving the right answer, right? No, 50, 53, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 6. 6 minus 3 is equal to 3. Right. 0, 1, 2, 3, 4, 5. 6 minus 3. 0, 1, 2, 2, 6. Adding this much and plus 1. Minus minus. Adding right sum taking right sum. Increasing. Adding the left. Okay, okay, okay. What happened? Okay. Why taking here? Why? This much. This one is the right answer. Just feel the condition now from this much to 6. Why 6? Why 6? Just like this. If, if, right, we are here like 2, we add like 4. That means we are taking here 4. So if we take 4, it has to increase 1. So 2 plus, we increase the 2 is equal to 2. We want to 2, 2, 1 and 2. We have add like this much only problem, and minus 2, 3 minus 2, 1. This much adding 4. Now we have to remove that 4 element from the starting one. This much. Just we have to maximize the answer for the last one. So, let's see. So we have added like a business problem like let's see, add the from the last, like add from the last and adding from the last. Now we maximizing the answer. Now let's see like sum and minus 3. Yeah. Now we have to right. We are maximizing the answer. Let's see this is okay. Okay. Why it? Why it? Why it? Why it? Uh, let's see this passes the test case or not. Yeah, this fits. So what I'm do here? What I do here? Like I take the first last kth element from the array and sum all it and the maximize with the sum. Now we check from taking the first element from the left and minusing the last kth element, right? That means if we take 1 here, so we have to take 1 6 from the last, so we have mm, mm, minus the sum of 5. Now if we take 1 2 1 2, then we have to take only 1 from here. Now we have take this, now we have to take a 0 from here. That's it. That's the main approach, the solution of this code, right? So I we able to solve the first 8 problem of this. Now let's move the hardest problem of the sliding window. Okay, so this is locked by the long. What is the problem name? You can find this question on GFG, distinct and unique characters. Now let's see what is the problem says. So problem says that you are given the as consisting of only lowercase alphabets and the integer k. Your task to find the length of the longest substring that contain exactly k distinct characters. That's the same problem. Okay, sorry, this is not that. With that, most of k distinct characters. Let's take the exactly character. Okay, let's see. So it's the longest substring like only k distinct character. Okay, or longest exactly. So this is the simple problem I think, because we are able to solve right this problem. I think, yeah. we solve this problem. I think, yeah, this is the problem of writing. Let's solve it. This is present on the Code Ninja platform. Let's let's first understand the logic behind it. Question: you are given the string str and the integer k. You have to find the maximum length with at most k distinct characters. So this is a simple problem. Let me see. At most distinct character. So the map size should not be greater than the k. That's the simple logic behind it. So let me see. Int count is equal to 0. First, I have to include width stdc plus plus dot h. Now left is equal to 0 is equal to 0. Oh, not a count here. Maximum length. Now check. Now we have to use unordered map character in frequency. Now we have to check. Now just we have to add frequency plus if the map the frequency size greater than equal to, sorry, greater than k, right? We have to like frequency str left minus minus if str left is equal to 0, so frequency dot erase is str left, right, left plus inside. Now we have to maximize the, we have to max length is equal to if the most maximum or max max length, right, minus left plus 1 max length, right. That's it. It passes the test case solved on compiler error int what is this? Between 920 and undefined. Okay. So we have to str dot size and compilation. Now submit the code. Pass. Yeah, this passes all the test cases. This is the very bigger question. Next, move this next question. So I solved it before, like I think, right? Now let's see sub-array with k different integer, right? Given an integer array nums and the integer k, return the number of good sub-array of nums. Good sub-array is where the number of the different element, okay, where the different element in the array is exactly k. If the exactly is introduced, we can use the at most problem or at least problem, right? We have to count, right? So let's see. Not let's see. Let's see longest. We have we solved, right. We just solved the problem like this. Yeah. Just we have to copy this much. Not a longest, but I can see that. I can okay. I can show you like in helper helper vector, right, in nums and int k. Now let's put the maximum not up. Let's count. Remove it. Count plus one, right, minus left plus one, right. This much frequency. Just add here this much. Now we have to check helper helper nums a minus helper nums a minus one, right. Just here add like if k 0 0, we have to return like 0. Let's say this pass the test cases or not. But still what is str this size. So we are using the str like str nums nums nums. Then can we not define the count value, right? Then count is equal to 0. We define why this. If we take at most 0 is exactly with the, I think this is right. Oh no right. I think it is right. Are you sure? Yeah, I'm sure. Let's see the element with a good way. Two. Like one, two, three, four, like one. So we have put them like let's say this much. Let's print out, right? Count. Let's see what will this say? Say enter 149. Calling about two at a time, right? So there is the size here. Okay. 14. 14 expected. Two different yeah, please wait a minute. One, two, three, yeah. Then one, two, three. One, four, three. I think this is right. Right? Why don't you remember left? Wrong answer. Left, left is good. 14. First, you try in case. Okay, use the 15. This is given 15. Right? Yeah. Just a little. I think this much change can bring it out result. Yeah, yeah. We can change here, like we can take here if, but we have to also check here, like if the MP dot size will be, oh sorry, frequency dot size, right? Frequency dot size less than equal to 8. Then we have to add this much. I think this much will might be the right answer. The wrong answer, that's a 5. That's much. Like, we have to do here this. Find the solution sorted, what solution accepted, what problem I solved today. So this is now let's cut it out. Right. Let's check the these two problem is good problem. So let's check out minimum window substring. So you are given like to a string S and T, and you have to return the minimum window substring such that every character in T, including the duplicates in it, is included in the window. If there are no substring, return the empty. Okay, so every character should be present on S, including the duplicates. The problem today defined. Let me just give me 1 minute. I got the mail. Like, just give me 1 minute, right? Just I got the mail. What this Just a minute. Give me just a minute. Yeah. Okay. 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 So let's go here. This sorry. I just solved the problem, but never this much. Yeah, I solved also solved the CSCS problem set. Like let let me show you. Right. I solved the problem. I solved the problem like what is that? Like any problem, right? Like I solved this problem. Let me figure out this this TP graph, not the fully graph because some are out of my league that I can do it. And the some I solved the sliding window problem here, right? Um, so you can find the all the problem like first three I added, and if I have time, I can add more on this, right? I can add and provide you the repo link of the solution of this all. Okay, so now let's see what is the problem state of. So we have to take like this. So just we have to make. First we have to take like and B O B C and A C A B B A B C. Like first, yeah, we get when we have this one the frequency in the yes, we have read. Now let's see what is D not study O not study P let's say E C and C let's say this will become this. Now we have to after this 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 much, right? All the elements are present here. Exactly, including the duplicate. Every character should be present. So the frequency of B is greater than equal to frequency of this. Then we have the count less than frequency less than, right? So let's see how can we solve this problem. Like I solved the quite today. I think I made first submission in 2015 December. Now let's see today I am able to solve or not. So let's do an ordered map like a character int and the first f1 and f2. Now we have to add t f2 barabar x plus 1. Now int the now we have to a string result result equal to 0 result. Now we have to take like right equal to 0 right equal to x dot size right equal to 0. Now we have to just take like add f1 dot as dot right right. Now we have to take like if f1 as dot right greater than equal to, of course we have to find like f2 dot count as 1 dot right if count and if f1 dot count if f1 as dot right if s dot right greater than equal to f2 dot s dot right, then we have to make cnt cnt right. Let's move f1 first s2 first f1 s2. Let's move the next question of the problem. Let's next step like while the while the all the character is found. Okay, just we have to just to cnt right. The cnt is greater to f1 dot f2 dot size dot size. We have to move just add the number na frequency and add with cam cam plus is equal to as dot right, right, added. It is not is the result dot minimum size. The result dot size less than the cam vector of the cam dot size से cam parameter. Simple the logic is now. Now just we have to remove from the starting. How can we solve it? Like it's right. We have to now just don't use this. Just tell me like if the right minus left plus one is equal less than the min length, right? So we have to add like a min length, right, minus length plus one, and start is equal to, right. Uh, now F1 F1 don't count. So F1 window size current F2 CNC minus one plus plus plus. So length is equal to 29. Then we have to only return the this passenger else and as for sub str start remain, yeah, then then should be 29. Let's remove it. Not the use right element, right? Okay, let's use the right, sorry, left equal to 0. Let's see this pass the test cases or not. It holds. If I is it's not calculating the calculation. Okay, sorry. It, I think it's still good. It is start like and the format and the form CNT format. The size should be minus 6. So F1 should be negative, right? F1 should be CH minus minus, right? But yes. F1 should be negative. Like reading part and the left with the mirror part. Common to reader. Okay, this much. Minimum length is not declared. I sure I declare here minimum length. So what's the problem? Okay. Left should be left start count int CNT answer minimum size. All is good. And start. Oh, I not define the start start should be 0. Start is equal to left. Start is equal to left. Now let's see the problem. You pick. Oh, there is no A in this. How it's possible? Here, this will be this, right? Let's give you the wrong. If S F1 dot right here, so we and is the CNT should be the size. Yeah. Side. Right side. It is like if the side is here, it is like character of left. It is it count one. Okay. That means here we have to F1. Then we have to do data management. I think this much all the problem. A D O B C K. This is a maximum now. It's a maximum element. Yes, maximum. I can't take a that is not able right. This count F1 dot count. You have to find in F2, right? We have to find the CS in F2. Okay, so I think this must solve the problem. Yeah, just like the test. Remember, so this PR. This much problem solved. Let's move the next question. Okay, this minimum window subsequence. Just copy here the paste. Minimum window subsequence. What is this problem? Say you are given to a string S and T. You task to find the smallest substring in S such that S2 is appear as the subsequence in that substring. Okay. Substring that means have to use substring. Characters will be present accordingly. I think this is going to solve tomorrow, yesterday. We can solve it. Just let's say the today POTT problem. Given two integer nums1 and nums2 sorted in non-decreasing order. Okay. Return the minimum integer common to both array. If there is no integer array, return the num. So two. Okay. So 1, 2, 3. Like one not present. So return the minimum integer common to both array. Okay. What then? So student is here. What? Yeah, it's present. Okay. Both are sorted, right? Present, not present. So return present, both common. Equal, not equal. Equal, yes. Just like this. Just check. You have to nums one greater than nums zero. One just get just solve the get common nums two nums one. Okay. And now let's check for the nums one dot five. Yeah, nums one five equal to nums two. Uh, then we have put the nums one I. Okay. Else the minus one. See? Let's see. This is going to pass or not. Either Okay. Okay. Just use the unordered map here. Just use unordered map. Just remove this. Just take size of it. And one. No. One dot size and two. Um, two dot size and two. Or and two. Follow. ठीक है. Into follow and to follow and transfer. Okay. Okay. And one. It has to dot count nums comes one I this much. So that's it. That's it today for me. Thank you so much for watching from my stream.